Alright.
Okay, ready?
Yep.
Okay. Sean, I want you to implement a cube using two stacks. So, first, I want to, before we jump into coding, I want you to briefly talk, show me how you would implement it. And can you share your screen?
Oh, whoops. Yeah. uh,
Yep. So the methods I want you to implement are actually just NQ and DQ.
oh, my handwriting is not good today.
Fine.
Oh, you know why? It's because I'm on two screens.
Uh, Let me start the timer.
There we go.
Mhm.
Okay, so we have NQ and DQ. So stack behavior. Yeah, this is not working out. It's like first in, first out. Uh,
That's Q.
yeah. Oh, that's a Q. Yeah, sorry. Let's do like 1, 2, 3. I can't draw straight lines. Alright, so let's say we like our input is like we NQ 1, 2, 3. We then DQ the
Well,
one,
yeah.
right? So I'm just mixing up my input so I can like test the functionality.
Well, for DQ, there's no input, right? It's just
Okay, yeah, yeah, I guess like it'll yield one.
okay.
And then maybe NQ 4
Mhm.
and then DQ will yield 2. Alright, so this is stack 1, this is stack 2. So one way to, when we NQ, we just push 1, and we NQ2, NQ3. So the moment we want to DQ, we want 1. What we can do is pop everything into from stack 1 to stack 2. So 3 will come out first and be in the bottom first. So it'll be 3, 2, 1. And then I'll pop this. So now we have 2, 3. So for any subsequent DQs, we already have everything in here. But if we need to NQ again, this will be out. If you want to NQ a 4, what we can do is pop everything from S2. The 1 is out. So it'll be 2, 3,
Mhm.
and then put a 4.
Mhm.
And then when we DQ, put everything here again. So it's like 4, 3, 2. and then it'll pop the 2. So that's one way to do it. Can I
What
make...
would the
Oh yeah.
Yeah, that's good. What would the runtime for that be? So what would the runtime for worst case runtime for both functions be?
Uh,
So let's say there are n elements
mhm.
in stored right now.
Yeah. So for NQ, let's say you popped, the worst case would be if everything was in S2, you know, because you DQ'd before, and you want to put something in here, you need to pop everything back. So it'll be N. For DQ, let's see. Let's say everything is in here. You want to push everything here and then pop, so that'll be N as well.
So I'm gonna say that there's actually a way to optimize this.
Yeah.
So you can actually so there's actually a way to optimize it. So one of these doesn't have to run in. One of these can run in just constant time.
Okay.
That's O1.
NQ. Let's see.
Oh, actually, I mean, sorry. So, actually, the word. So I mean, a worst case scenario. One of these will have a worst case scenario of just O1.
Yep.
Best case for both is, of course, constant time.
Yeah, okay. So, let's see. We NQ... I'm trying to think if we can use the other empty space for it. Maybe... Okay, so maybe like... Okay, the worst case being 1. So let's say you NQ'd 1, 2, 3. 1. Okay. What if we put 1 in first? That, okay, I guess like single elements isn't a good case. So what if we put 1, 2, three,
Okay, can I give you a hint?
Sure. I will take a hint.
So, when you DQ, if there is something already in the DQ stack, do you need to move the stacks around?
No, you do not.
Okay. And okay, let's see how should I put this. So when do you have to move? Um, Under what conditions do you have to move something to the DQ stack?
When it's empty, well,
Mhm.
the DQ stack, when all your elements are in the NQ stack.
Mhm. And you need to DQ, right?
Right. So so I guess like if we have 2, 3, 4 in the DQ,
Are, mhm.
and then we need to add something afterwards. Is this like an amortized big O?
No,
Does that have
no,
anything to do with it? Okay. Mm,
it's actually the worst case is always wait, hold on.
so when you swap from an NQ to a DQ, you have 1, 2, 3.
Yeah, one of them has a worst case of O1,
Okay.
not amortized worst case.
You have 3, 2, 1.
Oh,
DQ needs
hmm?
to know, well, the top element, that the last element that you NQ'd. Or does it?
So your solution before involved you transferring all the, the numbers from one queue to the other and back and forth, right? What if I told you that uh, what if I told you that there's no need to transfer them from
All of them.
ever from the DQ stack to the NQ stack? Could you think of a way to make that work?
So you have 1, 2, 3. Okay. We've DQ'd 1 here.
Mhm.
So now this is empty. Now we NQ a 4. Um, and then maybe, okay, let's say we NQ 4, we NQ 5, and then 6. And then we DQ everything. So 2, 3, 4, 5, 6. So it's 5, 6. Okay, so you can say, while this is not empty, keep DQing from here.
Mhm.
If it's empty, then you populate. Then you do the swap again. But isn't that still worst case of linear time?
For one of them, or why don't you tell me the run times for NQ and DQ if you did it this way?
So DQ, as long as there's something in here, I guess
Mhm.
as long as you're not NQing, then you're fine.
But the best case would be,
The best case would be constant time for DQ.
and the worst case.
The worst case would still be N.
Mhm. And what about for NQ?
NQ, right, so you just stick it in the stack, so that's
Yeah,
linear here. Got it, got it.
constant.
Yeah. Okay, now I got it.
Okay. So
Alright.
that's that's good.
Should I implement
Now,
it?
yeah, I want to see you implement it. So actually, uh, let's see. So there are two ways you can do this. One is to just use Cocher. The other one is to actually use uh, HackerRank, as this question was from HackerRank.
Okay.
And if you use that, you can actually run it to see if everything works. So would you, which
Sure.
option? The HackerRank.
I do HackerRank.
Okay, so the link is
Or actually, yeah, give me the link.
here.
I don't need to sign in, right?
I don't. Maybe not. Let's scroll down and see.
Okay.
Yep. Oh, you might. I think. Well, does it let you? If you go down and change the language to something of your choice? Okay, so you don't actually.
Okay.
All right.
Um,
So wait, this isn't.
that's a solution. Wait. Is this a complete solution?
Wait, this isn't the right. Hold on. That's not this. That shouldn't be the
Enter.
solution. It should be the question. That's weird. Yeah. Oh, this is it. Yep.
This one?
Yeah.
Okay. Oh, so you implement here.
Yep.
Alright.
And so what this does is, so the main method basically checks the operations for you.
Mm-hmm.
You just have to implement the methods here.
Okay. Um,
And you can also add helper methods.
yeah. Alright, so let's see. I guess we want to do enqueue first because, well, we're given, what, integers?
Yeah.
Next int, okay. T dot value. Okay, so it's generic type.
Right.
So I'll do enqueue first because that is the constant time. It doesn't depend on anything. So stack newest on top and stack oldest. Okay, so newest on top is stack 1. I can change this, right?
Yeah.
I just do stack 1 and stack 2. Whoa, this is fancy stuff. It's like code complete for me. So we just simply add to stack 1.
Mm-hmm.
If I want to dequeue, if stack 2 dot, where's my code complete? Anyways, let's do like this. Here we go. Stack 2 dot is empty. Stack 1 dot. While it's not empty, keep popping it. Stack 2 dot enqueue or add stack 1 dot pop. Let me just double check that pop is the right.
Yeah, pop
Okay.
is the right.
Right. Okay, so this should be okay. Just push everything and then
Mhm.
return stack 2. Well, first we want to check return. We want to check if stack 2 is actually empty first. Let's see, stack 2 dot is empty. If it is, return null. The lowercase. Yeah. Stack 2 dot pop. Okay. And then peek. So kind of the same algorithm as here, but instead of popping it, you just peek at it. So let's see. If it's empty, yes, then it's no. Okay, if stack 2 is already empty, populate everything from stack 1, then pop. Alright, so I can just click run to check.
Okay, sure.
T.add. Run code. Guess I need to log in. I'll do like my GitHub. Okay. Yay! Submit.
Now you want to. Yep. So I guess you can submit code to check whether you have it right. But,
Okay.
I guess normally in a coding interview you would walk through
Yeah.
the example, but that's fine. I mean, we've done this before, and I know you would do it. You'd have done it anyway. So yeah. So if you click on submit, then you can. It'll
Oh,
run
do a lot of test cases.
your code against some test cases.
Come on.
I think we're good. So yeah, that's
Oh, this is cool stuff.
yep. So
Cool.
good job.
Okay, well, yeah, thanks.
All right, I'm gonna stop the timer and give you some feedback. So
Sure.
that was 22 minutes, and I know we ran into some technical issues in between. So I think we did quite well on time.
Alright.
So you did well. I like that you define stack and queue behavior, even though it's we all know it, but it's good to talk through it so that
Okay.
the interpreter know that you've considered these things. You came up with the brute force solution quite quickly. That was good. So that gave you more time to work on coming up with a better solution. And I also liked how you did when you were coding, you checked at the end before popping from the stack, you checked whether it was empty first. So that was actually something I had missed. I didn't do it myself.
Okay.
Although one thing I would have done differently is, you see how in peek and dequeue there's repeating code?
I see.
I
Yep.
would have modularized that. I would have said maybe prepare stack 2 or something.
Yeah. Okay. Yeah, that's a good point.
That's pretty much it.
Alright, thanks Greg.
No worries.
Alright, and I'm gonna stop the stream right now. So I'll see you guys next time.
Bye, everyone.